All right, what's next? We're going down to page 82 this time. We're reviewing more rules for module 1. And this one, guys, we probably should use quotient rule. But you know how I don't like quotient rule, so I will rewrite this into this. E to the 7x times what? X times x to the negative 9th power. And I would rather do product rule. Okay, I'm just going to do product rule. Okay, so let's write down the product rule over here. First times the derivative of the second plus second times the derivative of the first. So the first piece of the multiplication is that red e to the 7x. We learned that the derivative of e to the 7x, something like that, is 7 times e to the 7x. Now, the g, the second piece of the multiplication, is x to the negative 9th power. The derivative of that is going to be negative 9 times x to the negative 10th power. Okay, we go down one on the exponent for these polynomial or power functions. Okay, not the exponential functions. All right, let's do the product rule. Start with first times, which is this red e to the 7x power. We're multiplying this by g prime. G prime is this orange. Let me put this orange G prime separate as like a negative 9 times x to the negative 10th power. Okay, so that's the same orange highlighted G prime, but I just separated them into two parentheses. Okay, plus sign. Now what's G? G was that second piece of the multiplication, x to the negative 9th power. And lastly, I'm multiplying this by f prime, which is 7 e to the 7x power. 7 e to the 7x power. All right, done with calculus. Let's do some algebra. Anything that we can factor out? Guys, I always factor out the e term first. I'll factor out that e term first, okay? I'll try to keep the 7 in a separate parenthesis of its own, okay? If I factor out that exponential term of e to the 7x, let's write down what's left. In the first part, we have negative 9 x to the negative 10th power. In the second part, if you combine these two, you'll get 7 x to the negative 9th power. So I think that's actually okay. Yeah, that looks pretty good. But, you can factor out more x's there too, right? I wouldn't really. I may just change it to something like negative 9 over x to the 10th plus 7 over x to the 9th. You see what I did was I put these x's back to the bottom of the fraction and made their exponents positive again. And if you may want to like add these fractions, okay, you can add these fractions, right? But first you need to make a common denominator. So easiest way would be to multiply the top and bottom of the second parenthesis of fraction by x over x, right? Because if I add extra x to x to the 9th power, that will be x to the 10th power. So that's what it's going to be. And if you combine these numerators, you will get, I'll put the 7x first, okay? 7x minus 9 and x to the 10th power in the bottom, okay? So that's, that looks pretty nice to me, so that's where I may stop. But the derivative, this was pretty good too, okay? But this, I love it. I love it. This is so cute. All right, so that was an example of example number 4 on page 82. I used up too much room, so let me add another page for example 5 here. I'll do this one. Copy this down here. Let's find the derivative of this function. Oh, it's a pretty bad looking function. Well, what you do is that we have to use a chain rule here, right? So we're gonna start with the derivative of this big outside function, which is e to the negative x squared plus 4x minus 7. Remember, if you have a function like e to the u power, okay? And you're taking the derivative of this with respect to x, then you have to write down that e to the u power, but multiply by the derivative of the exponent, okay? And the u will probably contain some x in it, but that's what we are doing. We're doing the chain rule here. So write down that exponential form exactly the same. But now what you're going to do is you're going to multiply this by the derivative of this exponent function. Okay, so what I highlighted in blue. Okay, so let's take the derivative of this. That will give you negative 2x plus 4. And usually, I guess we can switch the order of this. We can say our final answer is, I necessarily wouldn't, I would, because I like to keep a term that is not raised to a certain power first, and then I will write the term that has an exponent after. But both are the same thing, and it seemed difficult, but only thing that you had to do was copy down that exponential term exactly the same, because derivative of e to the u is e to the u. So bring that red thing down exactly the same, but make sure to multiply that by the derivative of the inside function. Okay? All right, how about last one, number 6? Gosh, I may need to stop this video and have a separate one for this. I'm a little concerned about this. I'll put this one down here. It's 3 terms, and I think the last one is pretty easy over here. Okay, but let's see what we have to do. I'll separate this out. Okay, I'm gonna find the derivative of x times e to the negative 5x power. So this is me just writing out my plan. I'm going to add that to the derivative of 3 times e to the negative x power. And the last piece, I will add it to the derivative of x to the 9th. So we got black, red, and blue things to deal with. And look at the last one. That's the easiest, right? The derivative of x to the 9th power is simply 9x to the 8th power. But this red and the black, that's going to be tricky to deal with. The red isn't too bad either, right? Look at the red. The exponent of negative 1 will come down and multiply with this 3. So you will have negative 3 as a new leading coefficient, but you keep that exponential term exactly the same. So I'm done with the red and the blue. But you see the black one, this one right here, that we gotta use product rule on this. So let's see if we can do the product rule without writing writing out the whole thing, okay? So the product rule goes like first times the derivative of the second plus second times the derivative of the first. So I'll do that down here, okay? So let's start with writing the first. First is x. X times the derivative of the second. What is the derivative of e to the negative 5x power? That is negative 5 times e to the negative 5x power. Plus, second times, second is e to the negative 5x power, times the derivative of the first. Derivative of x is just 1. See, this is, I think, the very first time I didn't really write out all the pieces of product rule and just did it. But I think you guys have been doing this product rule so many times already that some of you are probably doing this already mentally, okay? So I wrote this down. We just need to clean this up a little bit, okay? How can I clean this up? Look, I may be able to factor out this. Maybe not. Let me try to write it all out and see if we can. I don't think we have any like terms though. All right, maybe I can just simplify this, okay? Let's simplify this first. I'll bring out that negative 5 first, stick that x there, and write down the e to the negative 5x power, okay, plus, well, that's just going to be e to the negative 5x power, right? All right, and then I will just bring these down. You want to simplify this any further? I guess we can try to factor this out from the first 2 black terms. We can factor those 2 out and write it as e to the negative 5x outside and write down the leftover. What's left? Negative 5x is left. And if you divide e to the 5x by e to the negative 5x, Well, that's going to be 1, right? So you will still need to write down plus 1 there. But that's pretty much it, right? I can just mindlessly copy these two terms down. But it really doesn't simplify any further, and it looks pretty okay. So I would stop here. This started as just a sum of unrelated looking terms we took the derivative of. So the red and the blue were pretty easy, but then the black one we had to use a product rule and try to simplify it. But that is how we can take the derivative of this function y.